For Unit 7, Objective 6, we're converting from the general form of a parabola to the descriptive form of a parabola. And we've been using the descriptive form throughout this entire unit because we like to know things like where's the vertex, what's the focal chord length, and it helps us find the focus and the directrix. But we're not in that form right now. We're in what's called the general form. I already know something about the parabola simply by looking at the equation. When I have y equals x squared, the parabola is either going to go up or down. And since that leading coefficient is a positive 3, what it means is the parabola is going to go up. So we already know simply by looking at this, we know it's an up parabola. But the next question is, what's the vertex? What is the point that represents the vertex? Well, to answer that question, we're going to convert from this form to descriptive form by completing the square. Now, we've already completed the square earlier in this unit, but we haven't done it when there's a leading coefficient, so that leading coefficient is going to add one little additional step. So the first thing we're going to do is we're going to get the constant over to the other side. So I'm going to move that 7 over here, and I'm going to have y minus 7 equals 3x squared plus 24x. Now, over here, I'm going to factor out that 3. So y minus 7 equals 3, and then in parentheses, x squared plus 8x. Because I factored out the 3, so both of these terms got divided by 3. Now I'm going to complete this square. So y minus 7 equals 3 times x squared plus 8x plus that third missing number that's going to complete the square. So we do it like we always did it before. Take half of this number. Half of 8 is 4. 4 squared would be 16. Now here's where something a little bit different is going to happen. In the earlier objective, whatever we added over here, we would add the same number over here to keep the equation in balance. But that 3 means I don't just add 16 to this side because that wouldn't be balanced. This 16 is being multiplied by that 3 if I were to distribute it. I'm not going to, but if I did, that 16 on this side would be the equivalent of 48 on this side. And the way I got that 48 was this 16 multiplied by that 3. So now my equation is y, if I take a negative 7 and add a 48, I get 41. Y plus 41 equals 3. Now over here on the right, I've got a perfect square. And that perfect square is x plus 4. Because remember, it's always this 1/2 number that we use to complete the square that makes the perfect square. Now I'm almost in descriptive form. All I've got to do is move that 41 over to the other side. So now I have an equation that says y equals 3 times x plus 4 quantity squared minus 41. Now I'm in descriptive form. And what was the benefit of the descriptive form? I can tell you exactly where the vertex is right now. It's the opposite of this, so the x-coordinate is negative 4, and it's the same as that, so the y-coordinate is negative 41, so the vertex is negative 4, comma, negative 41. Okay, here's my second example of converting from general form to descriptive form. Now, again, I already know something about this parabola, since it's x equals negative 5y squared. Because of that negative, it's going to open up to the left. When it's x equals, it either opens to the right or to the left, and since that's a negative number, I know the parabola is going to look something like that. But the big question is, again, where's the vertex? Well, in order to answer that question, we're going to go from general form to descriptive form. So the constant moves over to the other side. So when negative 11 moves over there, it would be plus 11. X plus 11 equals negative 5y squared plus 20y. Now, I'm going to complete the square with the y's. So x plus 11 equals, factor out the negative 5, and you would have y squared. Now 20 divided by negative 5 would be negative 4, so minus 4y. And remember, we're completing the square, so we're going to add that third missing term. Half of negative 4 is negative 2. Negative 2 squared is positive 4. But since that 4 is actually getting multiplied by that negative 5, I wouldn't just be adding 4 to this side to keep the equation in balance. I would have to add 4 times negative 5, which is negative 20. So to keep that equation in balance, since I added 4 right here, I have to add negative 20, 4 times negative 5, negative 20, to keep the equation in balance. Now, a positive 11 subtracted by 20 would be x minus 9 equals negative 5. Now I have formed a perfect square right here, and that perfect square is y minus 2 quantity squared. And now I'm going to take that constant back over to the other side by adding 9 just to the end of the equation. And now I'm going to have x equals negative 5 y minus 2 squared plus 9. So there's my equation. Now, what's the vertex? It's really easy to make a mistake and go positive 2, 9. This parabola is turned sideways. Okay? This is actually telling you the y-coordinate of the vertex is positive 2. It's always the opposite of whatever's in the parentheses. So that would be positive 2, but it's the y-coordinate that's positive 2, not the x-coordinate. So it's the opposite of this, same as that. So the vertex of this parabola would be at 9, 2. Okay, here's my third example. The numbers are going to get a little bit trickier because of the fraction, but I promise you there is nothing different that we're doing on this example than we've done on either of the other two. So first of all, looking at the equation, we have y equals negative 1/4 x squared. So that already sets up, since y is the variable to the first power and x is what's being squared, we know this is either an up or a down parabola. And because the leading coefficient of the x squared is negative, we know this is ultimately going to make a down parabola. But again, the big question is, what's the vertex? And descriptive form will help us answer that question. So, like any of the others, we're going to move the constant to the other side. So that would be y minus 5 equals negative 1/4 x squared minus 3x. Now, the next thing we're going to do y minus 5 equals, the next step in the other two examples was factor out the leading coefficient. Well, it's the exact same step we're going to do here. It just happens to be a fraction. So I'm going to factor out a negative 1/4. And what that's going to leave me is x squared, but what's the next term? When I divide negative 3 by negative 1/4, it's the same thing as multiplying negative 3 by negative 4, and that's going to give me plus 12x. Now the next one, y minus 5 equals negative 1/4 x squared plus 12x, and then we've got that missing number. We're going to complete the square. That square gets completed by taking half of 12, which is 6. 6 squared is 36. But remember, this number gets affected by that leading coefficient. 36 times negative 1/4 is negative 9. Now I have y minus 14 equals negative 1/4, and the perfect square that I just created is x plus 6. And my last step is move the 14 over to the other side, and I'm going to have y equals negative 1/4 x plus 6 squared plus 14. And that's going to be my final equation in descriptive form. So what that's going to show me is my vertex, which is at negative 6, 14.